Okay, so hello everyone, my name is Anubhav Mondol and today I'm going to solve one problem which is based on organic mechanisms, and this would be mainly for your JEE mains and NEET exam. It is on an easier side. So I'm Anubhav from 4-year BTech course of IIT Kharagpur. So the substrate is here. It contains a keto group and an ester group, and for the reagent that we have along with it, it is actually ETONA, and ETONA is a very strong base. Okay, and you know that the characteristic of a strong base is to, abstract the acidic hydrogens of the substrate with which it is reacting. So we have to find out the acidic hydrogens where they are and abstract them accordingly and proceed. All right. So this is one important thing that you have to remember. Okay then. So now let me start by solving this question. All right. So let me erase all this information and let's see what is the mechanism, and I would teach you the required theory along with it. Okay, so let's start. Okay, so let me start by drawing the given substrate here. So this is the substrate that we have been given. It contains a keto group and an ester group along with it. So now we have to identify which of the following, there are many hydrogens. Which hydrogens are acidic hydrogen? We have to identify that. So the two hydrogens here and two here are the acidic hydrogens, and ETONA being a strong base would abstract any one of these hydrogens, since there is one molecule of ETONA to react with one molecule of the given substrate. Okay, so as you can see that there are two acidic hydrogens which are similar, these two, and another two, these two are similar. Alright, so either this or this acidic hydrogen will be abstracted in this case. Okay, so we have to check which acidic hydrogen has to be abstracted. So for that we need to check the stability. Okay, whose stability of the final product, or the stability of the intermediate product in this case, which is formed after abstraction of acidic hydrogen. And to check that, we are going to use the theory of resonance. Okay, we are going to check its resonance stabilization of the intermediate that is formed after the abstraction of hydrogen, and from that we can understand what is going to happen. Okay, so let's proceed to find out the what is going to happen here. So okay, now let me draw it again. Yeah, let me draw it in green. So here is our substrate, and let's abstract the acidic hydrogen here, so we get a negative charge here. And if we check the resonance here, let me draw the lone pairs of oxygen in this case. Yeah, so as you can see, the resonance takes place like this. All right, so and from here, okay, the electrons can movement. So as you can see, there is a wide amount of resonance, cross resonance taking place here. So the resonance is quite extended in this case. But if we abstract the acidic hydrogen from the other side of oxygen here, the resonance is very limited. Only just one position of resonance takes place there. So it's not favorable actually in this case. So this resonance is what we want, and we are going to proceed with this. All right. um so ETONA is going to abstract the hydrogen from that position. Okay, and that hydrogen needs to be an acidic hydrogen. So let me draw the substrate again. So this is the substrate with the negative charge on it, and so the next reagent that is going to attack it is a cyclic ketone or a lactone with a double bond. So one thing that you need to understand very well or know very well in this case is that in this kind of compounds where there is a highly stable enolate, okay, there is a highly stable enolate, it always does conjugate addition, okay, it adds in the conjugate position always. So that's a characteristic nature, okay, and you need to remember this, and this is a very important reaction as well. So conjugate position, yeah, okay. So now it would attack here and the double bond would go up, all right. The double bond will go up and the double bond of oxygen will go up and appear as a negative charge on the oxygen. So the final product now is going to look like this. Alright, so this is the product, and here is the side chain, that is a side ring that is attached with it, oxygen minus and a double bond, yeah. Now as you can see, you must remember the concept of tautomerism, okay. The acidic hydrogen that we had extracted is an H plus remaining here, and in presence of that medium, this compound is going to tautomerize, okay, because we see the negative charge on oxygen and a double bond here, so it's gonna tautomerize. And what's going to happen next is like this, something like this. Yeah, next we draw it again. Okay, so after tautomerization, this product looks like this. Now we are going to add dilute KOH as it was given in the question. Alright, so okay, so dilute KOH is given. Now we can see that there is a very good living group here. Can you identify it? Yes, it is the OR group that is attached here in our given substrate. Alright, and I mean the KOH being a strong base is gonna attack there only. So the most vulnerable position in this substrate is here, this OR group, and as you know that OR is a very strong very good living group, so it is gonna live like this when the OH attacks, and what's gonna form instead is and salt of carboxylic acid is gonna form here. Alright, so the final product here now would look like this. It would be a salt of a carboxylic acid, most favorably a beta keto acid here. Alright, so salt of a beta keto acid with a side ring attached to it with a ketone group here. Alright, so now what happens is that we do the acidification process. Alright, it is a salt of a carboxylic acid. Okay, so let's see what's given next. Okay, next it is asked to do the process of acidification, and then we are going to add heat to it. Alright, so let's move ahead. Yeah, so as we come up here we can draw it once again. So next we are going to do acidification on our given substrate. Alright, so acidification means that the salt is going to be converted into the carboxylic acid respectively, right, by the addition of H3O plus, in the H3O plus medium. So finally what we get is a beta keto carboxylic acid here. Now we are very close to our final product, okay, and what is asked is to heat it. Alright, so when we heat it, we heat it mildly or whatever we do. As you can see that this is a beta keto acid group, okay, the acid is here and the ketonic part of it is attached along with it, and we are heating it. So what happens is that decarboxylation takes place due to mild heating. You must remember this concept of decarboxylation, and it's very important. I mean, with respect to JEE means NEET and even in JEE advanced. Alright, so what happens here is this. So there is a CH3O double bond O. There is a CH2 finally, which there is a CO2 that goes out due to decarboxylation and heating, and the H that is attached comes over here to form the CH2 group, and from here there is a lactone group attached with it. Yeah, so this is the final product that we were expecting and we got it, and this is the final answer as well. Okay, and so this is the product that was asked in the question, that was asked for in the question, and we get it eventually. So this is the mechanism, and this is an easy mechanism based problem. Okay, so you must remember two important things here. You learned two important things here: the acidic hydrogen concept and the concept of decarboxylation. All right, decarboxylation, yeah. And another important thing that you need to remember is to look out for tautomerism, because that is also a very hot concept that comes up. So this is a beta keto acid here. Okay, if you want to look into the beta position, let me show you. So in this case, as you can see that the acid group is here, so the next carbon is the alpha carbon, and the carbon after that is the beta carbon. So in a beta keto acid, when the CO2 leaves, the cyclic intermediate is formed, and that stabilizes the final product here. So on mild heating we get decarboxylation here. Alright, so I hope you liked the video. Okay, so give a thumbs up and comment and ask for any doubt that you have. So thank you very much and goodbye.